I'm not finished yet. I'm not finished yet. Okay, so here we go. Begin with rational expressions and stating the excluded values of each. 26 questions. Proceed. The excluded value here will be 0. And here it will be 0 as well. Check. Correct. Factorizing the denominator. We have m add 7 times n take 3. Now, I believe that this excludes negative 7 and 3. However, they may be of the opinion that what you do is you cross those out, and so it's only 3 that's excluded. But we'll see. Likewise, over here, I recognize that the numerator can be factorized into n add 1 times n add 5, and so they could potentially cancel the n add 1, and so the negative 1 that I think is excluded is actually not. We're about to see. No, it's I'm actually correct about that. Now, I want to know what the relevant terminology is. Suppose someone has the rational expression m plus 7 over m squared plus 4m take 21. This can be factorized into m add 7 all over m add 7 times m take 3. Someone may, at this point, someone may say that negative 7 and 3 are excluded values of the domain of x. But someone else may cancel the common factor of, put cancel in quotes, the common factor of m plus 7 on the numerator and denominator, and then conclude that only 3 is excluded. Please clarify this confusion with relevant terminology. Is it the case that 3 is somehow more intrinsic, more included, or what have you? Okay, I'll send this to GPT and Gemini and see what relevant terms I can get. This is actually a valid use of these creations. Of course, it takes a while for them to load, possibly because of the streaming. A rational expression is undefined wherever its denominator equals 0. True. The domain of the original expression includes both m equals -7 and m equals 3. Simplifying, you get 1 over m take 3, but the simplified version is not fully equivalent to the original everywhere. It's only equivalent for values of m where m at 7 is not equal to 0. The simplified form agrees with the original, except at m equals -7. Okay. M equals -7 is a removable discontinuity. The graph as a whole at that point. And that's a non-removable discontinuity. Vertical asymptote. Okay. Continuing on. In this case, we want to know when that's equal to 0. So 25x equals 40. So x equals 40 over 25, which is 8 over 5. Eight over 5 and 7. Oh, beg your pardon. -5 and 7. Gotcha. Now, simplify each and state the excluded values. Right, okay. So that'll be 1 over p add 2. And the excluded values are -4 and -2. And here, the excluded value is simply 1, but you can simplify this to this. Yeah, I mean, it's simplified, but like, yeah. All right, let's see what they mean. No, they mean exactly what I said. All right, okay. Common factor of 2a. and here of 3a. Excluded values. Oh, beg your pardon. That's just literally 2 over 3. But a is not allowed to be 0 or -5. Perplexing. We'll resolve that momentarily. Just continue and try this next one. Gotcha. So exclude 1 and -2. That will make sense, but this one, I don't know. I want to know what that means. So an expression has been simplified to a constant, but also somehow, like, I have to retain information about what's excluded. Why? Okay. I'm going to resolve this. It's the only way to understand. The only way to understand. Okay. 2a squared plus 10a over 3a plus 15a simplifies to 2/3. Yet, in the answer book, I am told to still mention the excluded values of 0 and -5 that the original rational expression bears. Why is this so? If it has okay. Always ask 2 or 3 of them and see. Right. The simplification is only legitimate where a is not equal to 0 and -5. Okay. I'm fine with this. All right. Okay. Correct. Like, you can only do this simplification when x is not equal to 6 over 10 or 3 over 5. So I don't want to say but only when x is not 3 over 5. Understood. Okay, next up, obviously we exclude -10 and -8. But when we do this cancellation business, they cancel, that flips, and that cancels, and then we get a v minus 7. So it simplifies to v minus 7, where v is not -8 or 10. Likewise here, n is not allowed to be, it's not allowed to be -2 or 1. Not allowed. But simplifying, so we scratch off, that turns into 1, and then we flip it, and so we get n take 1 over n add 2. There's the simplified version. Okay, how come? Oh my goodness me. Because that's a piece of arithmetic there, and it turns into this gigantic. Okay, let me explain. That's a piece of arithmetic there. You evaluate it, and it turns into this giant expression here, giant rational expression here, like this. And this has excluded values of -2, 1, and -3. That's why. And then you simplify the expression by cancelling out common factors on the numerator and denominator. Okay, right. Don't be caught out again. So here, this turns into over there. The excluded value after performing the arithmetic is this. X cannot be -3. Now make the full simplification, and we go cancel, cancel. So x minus 6 over 4. And x cannot equal minus 3. Right? Now, we do the arithmetic, and we get this giant expression on the top. And on the bottom, so write out x may not be negative 6, 8, or negative 10. And now simplify cross, 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 cross. So 4x over x add 6. Okay. Lovely. All right. I'm getting it. I'm getting it. Okay. Do the arithmetic. Factor out that 2b. That doesn't have any effect on anything. That's who's excluded. And cross, 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 cross. 2b. Here, flip it. Factor out 3. It would seem like nothing can be done, but obviously these are negatives of each other. So, if you have like that on the domain, so it's negative 3 over n add 9. I believe. Good. Continue. That's the arithmetic complete. Who's excluded? The answer is 4. B may not be 4. And now simplify things. So we have negative 7 of b add 10, but they may write it as negative 7b take 70. And moving on now. Okay, so we've got 2. What's this going to turn into? Take 9, take 3. Arithmetic done. Who's excluded? But only when b is not 3 or 9. And check. And that's correct. That's not correct though, so fix it. Gotcha. accidentally flipped it. Be more careful in future, yes? Better. Continue. Flip them. So on the numerator now, we will have 5p squared. P, take 7. And on the denominator now, we will have P may not be 0 or 4. There. That's the arithmetic done. Now, before we simplify, we will say who is excluded. X may not be -8, and it may not be 1. Now simplify. Okay, so those cancel. That turns into its negative self. And so we have negative of x at 5 all over 9. Valid. -4, -10, or 9. Excluded. Careful there. Negative on the top, so Now, before I simplify, I would say that x cannot be 0, it cannot be 2, and it cannot be -5. And now simplify. (160) x cubed over 240 x squared. Well, that turns into 2/3 of x. Oh my goodness me. Wait, no, I actually genuinely don't understand that. Why isn't that x at 4? Oh, because I excluded the wrong one. Ah, with the carelessness. That's actually fine. 9, -4, -10, right, okay. 2/3 of x, excluding those. Okay. Better. And now to add and subtract rational expressions. Okay, I believe this is simply 7u take 4v, and it's all over 8v. Right, and put these together now. Well, the m's cancel, and then we have -3 and take 3. So I believe it's -6n all over this. And we cancel, and we can actually simplify this, but dare we do it? Okay. Given like what we just did, right? I mean, here, of course, n cannot be 0 and m cannot be 0, but I wonder what I have to say. No, it's all okay. It's valid. So that's 5a at 6. There's nothing to do. I mean, down there I can just say, oh, it's a add 2 times a add 1. And we'll see if that counts as simplification. Adding on 5, so we get n take 1. Must factor out 2. And then we get 5n squared at 8n. Like that, and we're about to see. No, they really do just want us to just mindlessly add the numerators right now. Well, forget them. I consider factorization to be simplification because it's more useful in many contexts. And plus, I just want the exercise anyhow. So it'll be 2r at 7 on the top and 3 times r take 2 on the bottom. And it would literally just be -1 all over. And does this factorize now? We do b squared minus 4ac, so 169. Take away 160, so that actually that can. So let's try and do it, eh? Nice. And check. And valid. That times that, take away that times that. All over 4x, take away 4. But is that what they want? I don't know. We'll see. It is. It pretty much is. All right, so for this, well, you better expand it out. No, they want a factorized form on the bottom. And when we expand it out, we get 7x squared, so it's 42x squared. (28x), so that's 23x, and then 23x times 6 is 138x, and 138x becomes 137x, and then we have negative 20, so negative 120, so negative 115, I believe. Let's negative 120 take 5 is negative 125. Okay, that's good. All good. Three x take 24. 4x at 28. Take 24 and 28. We may take a little bit of a break here. Yes, we may take a little bit of a break here. We're just going to finish this 10th one, and then we'll take a break because we've got to pace ourselves through this. Very annoying sound in the background at the moment. Anyway, just to sort of like brute force it here. Okay, times the top and the bottom by 2v squared at 2v. Right, that's quite enough for now. All right, we'll be back later. And besides this, it's not too instructive, that module. What I really need to take on is yes, what I really need to take on is the conics, because I don't know that well enough. But okay, I'll be back. Be well.